All right, don't be scared. The question actually looks elaborate, but it's simple. Solution. Now let's write the nuclear equation. All right, in our last video, we did see that these are the three general uh, nuclear equations. All right, for alpha decay, beta, and gamma decay. Is that okay? And we also saw that mass number is equal to proton number plus neutron number. Do you remember? A neutron number will be equal to mass number minus proton number. So the first question here says we should state the number of neutrons in the nucleus of americium 241. Okay, now looking at the nuclide, mass number is the one on top, that's 241, and proton number is the one beneath, that's 95. Okay, therefore neutron number will be 241 minus 95, and that will give us 146. Okay, so the number of neutrons in the nucleus of this guy is 146. II says determine the values of A, B, and C. Okay, now since I know that alpha particle is equivalent to, or it has the nature of the helium atom, 4 up and then 2 down. Therefore means that A is equal to 2 and B is equal to 4. It's as simple as that. Is that okay? Now to find C, I can either say 95 minus the charge for the alpha particle, which is 2, and that will give me 93, or I can write it in form of equation. 95, that's the left hand side. The left hand side, remember, it must be equal to the sum of the proton numbers in the right direction. So C plus A, of course, is 2. This one is right hand side. Okay, so C will be equal to 95 minus 2, which is 93. So that's the answer. All right, question number 5. Again, we are asked to determine the value of X. So we have Rn now I can rewrite this like this: beta plus beta. Here is 0, here is minus 1, here is 0, here is minus 1. If I like, I can as well rewrite it like this. Okay, 2. Okay, or now I use this 2 to multiply the mass, and it will still give me 0. And then 2 times minus 1 will give me minus 2. Okay, so these are the 3 ways you can represent the nuclear equation. All right, so Now, we've already seen that the emission of a beta particle does not impact on the mass number. Is that okay? So I already know that X is equal to 222, which is option A. But let's imagine that they asked us to find the proton number, this one. So, of course, what will it be? It's already 88. Of course, did you notice that we said the proton number of the daughter element will increase if a beta particle is emitted? All right, I think that's all I can say. The answer is 222. Okay. Now, number 6, we are asked to find. So let's write the nuclear equation: 2, 3, 5, and then 92. Okay, so the daughter element, I don't know, but I can represent it with X. But we are told that 4 alpha particles and 3 beta particles were emitted. So you can write like this: 4 alpha, remember here is 4, here is 2, and then 3 beta, 0 minus 1. Okay, so if I want to rewrite this, just like we did before, it will be X, and then I have, remember this 4 will multiply this 4, so here will be 16. The mass of the alpha particle will be 16, and then this one will be 4 times 2, that is 8. It's actually wrong to write it like this, but it's okay if it will help you to arrive at the correct answer. So this one would be 3 times 0 will give us 0. 3 times minus 1 will give us minus 3. So if you also write it like this, it's okay. All right? Please, this should not be written like this, but for the sake of this problem, it's okay to write it like this. All right. So what do you think they're asking us to find this guy and this guy. So what do you think? We can write it in form of equation. I already know that the mass here will be a function of this only. This one has nothing to do with the mass of the daughter element, right? So it will be 2, let me write it, 2, 3, 5, and then here is 92. So 235 minus 16 will give us this one. So it will give us 219 rather. 219. So 235 minus 16 will give us 219. And here, 92 minus 8. So I can do something like this. 92 is equal to, I can call here X if I like. You can use equation to, help you get the correct answer. X plus 8. And then here we have minus 3. Okay. So here we'll have X plus 5. Do you remember? Okay, so that means X will be equal to 92 minus 5, which will give you 87 rather. 87. Okay, so the correct option is A.